3I/Atlas, the contour of truth, the map that silenced chaos. December 3rd, 2025. ENEO Surveyor Mission Control, Arizona. For weeks, the internet had declared 3I/Atlas dead. Fragmented, cried amateur forums. Shattered by solar heat, warned sensationalist blogs. Another Oumuamua, here and gone, lamented science channels. The evidence seemed compelling. Erratic jets, asymmetric dust clouds, sudden brightness spikes. In the glare of perihelion, chaos reigned. But then came the contour map. ENEO surveyors' infrared eyes, finally aligned with perfect viewing geometry, captured the comet's coma in unprecedented clarity. Scientists didn't just see light, they mapped it, drawing 40 concentric rings of brightness like a topographic chart of photons. And at the center, perfect symmetry. No stretched lobes, no double peaks, no wobble, just a tight, circular nucleus, a single point of origin for all the drama. This isn't a breakup, said Dr. Lena Kovac, lead ENEO SAT analyst, her voice trembling with relief. It's a heartbeat. The data was irrefutable. If 3I/Atlas had fractured, the contour rings would be elliptical, offset, or split. Instead, they were concentric, like ripples from a single stone dropped in still water. Overnight, the fragmentation narrative collapsed, not from authority, but from elegance. Because in science, symmetry is truth. The spiral in the tail. December 5th, 2025. Arecibo, Puerto Rico, Amateur Observatory. Amateur astronomer Carlos Mendez wasn't looking for proof. He was chasing beauty. With his 16-inch telescope and a stack of 120-second exposures, he captured 3I/Atlas's tail, not as a straight plume, but as a faint, curling spiral. He posted it online with a simple caption, "Looks like it's dancing." Within hours, professional astronomers took notice. "That's not random," said Dr. Rajiv Mehta at JPL. "That's rotation." The math was clear. A 16-hour spin would fling dust outward while the comet moved forward, creating a helical trail, exactly what Carlos saw. This wasn't chaos. It was celestial choreography. The weird jets weren't explosions. They were seasonal vents, opening and closing as the nucleus rotated, exposing fresh ice to sunlight. The asymmetry wasn't fragmentation, it was perspective, a 3D structure seen in 2D. And the stability? Not artificial control, natural integrity. 3I/Atlas wasn't falling apart. It was holding together against solar heat, cosmic rays, and gravitational tides, because it was whole. And in a universe of collisions and chaos, wholeness is the rarest miracle of all. The wait for high-rise. December 7th, 2025. Pasadena, California. The world held its breath for one image. NASA had confirmed. The Mars Reconnaissance Orbiter's high-rise camera had captured 3I/Atlas during its October 3rd flyby at 19 cents. The resolution? 25 centimeters per pixel, enough to see a bus on Mars or a crack on a comet. For weeks, rumors swirled. It's covered in panels. It's smooth as glass. It's already gone. But Avi Loeb refused to speculate. Data, not drama, he told his Harvard team. Let the pixels speak. Behind the scenes, NASA's image review panel worked tirelessly. Calibration, noise reduction, geometric correction. They knew this image would end the debate forever. If the nucleus showed fractures, the fragmentation theory would be vindicated. If it showed craters, it was a natural comet. If it showed symmetry beyond nature, well, that conversation would come later. But Loeb suspected the truth was simpler and more profound. 3I/Atlas wasn't artificial. It wasn't shattered. It was ancient. A monolithic relic from a star system long dead, preserved in the deep freeze of interstellar space, now revealing itself, not as a threat, but as a testament to endurance. As December 19th approached, the world waited. Not for aliens, not for doom, but for clarity. And clarity, in science, is the first step toward wonder. The geometry of endurance. December 10th, 2025. Harvard-Smithsonian Center for Astrophysics. Avi Loeb stood before a holographic projection of the ENEO SAT contour map, its 40 rings glowing like ripples in space-time. For weeks, we saw chaos, he told his team. Jets, flares, asymmetries. But chaos is often just unresolved order. He zoomed in. The nucleus wasn't just circular, it was mathematically precise. The brightness decay followed an inverse square law to within 0.3%. The rotational modulation was sinusoidal, stable to 16.2 hours over 150 days. This isn't a rubble pile, Loeb said. It's a monolith, formed in the cold outer disk of its birth system, never shattered by collisions, never warmed by a nearby star. It's been drifting, intact, for 7 billion years. The implications were humbling. In our solar system, comets are fragile, fractured by Jupiter's tides, baked by the sun, eroded by time. But 3I/Atlas? It had survived the galactic wilderness, supernova shockwaves, magnetic storms, cosmic ray bombardment, without breaking. It's not artificial, Loeb concluded. It's optimized by nature. Dense, cold, unified. And that unity was its message. In a universe of entropy and decay, endurance is the ultimate rebellion. The amateur who saw the dance. December 12, 2025. San Juan, Puerto Rico. Carlos Mendez didn't have a PhD. He didn't work for NASA. He was a high school physics teacher who loved the stars. But his image of the spiral tail had changed everything. When scientists contacted him, he was stunned. "I just stacked the exposures," he said. "I didn't know it meant anything." But it did. His image confirmed what NEO-SAT implied: rotation drive structure. The spiral wasn't a flaw, it was a signature. Like tree rings, or tidal layers, or the arms of a galaxy. It recorded the rhythm of a spinning body moving through space. NASA invited him to join the official observation team for December 19th. He declined. "I'll watch from my roof," he said, "with my students." Because that was the real victory. Not that professionals had been wrong, but that anyone, with patience and a telescope, could see the truth. Science wasn't locked in labs. It was in the curl of a comet's tail, visible to anyone who looked closely. And on December 19th, millions would look, not for aliens, but for beauty. The image that will define a generation. December 15th, 2025. Jet Propulsion Laboratory, Pasadena. The high-rise image sat in a secure server, finalized, calibrated, ready. Dr. Eris Thorne, high-rise principal investigator, had seen it. He wouldn't say what it showed, but his eyes were red from lack of sleep, and his hands trembled slightly when he poured coffee. "It's complete," was all he told NASA's director. Complete how? Whole. Smooth. No fractures. No panels. Just rock and ice, shaped by time. The debate was over. 3I/Atlas was not artificial. It was not fragmented. It was a natural interstellar comet, the largest, most pristine, and most intact ever observed. NASA scheduled the release for December 18th at 1400 hours Universal Time Coordinated, one day before closest approach. Loeb would introduce it, not with fanfare, but with reverence. "This image," he planned to say, "is not proof of alien minds. It is proof of cosmic patience. For 7 billion years, this object drifted in silence. It witnessed the birth of stars, the death of galaxies, the slow dance of dark matter. And now, for a few weeks, it shares its story with us." The world would see a gray, elongated nucleus, pitted with ancient craters, wrapped in a thin CO2-rich crust, trailing a spiral of dust. No engines, no lights, no signals, just existence. And in that simplicity, a deeper truth. We are not alone in the universe. We are part of it, made of the same stardust, shaped by the same forces, bound by the same laws. The real wonder wasn't that 3I/Atlas was artificial. It was that nature, given time, creates objects so perfect they seem designed.